Howdy folks, welcome back, and we're going to continue our function analyses, and we're going to now look in difference quotients. So difference quotients are another application of function notation and whatnot, but it's specific to looking at how a function changes between 2 points on that curve or that equation. So let's look at some of the technical terminology. So what we're looking at are difference quotients. And the way we can kind of think of it is as in terms of an average rate of change of a function. So similar to the slope of a line, we can find the average rate of change of a function between 2 points on the function. So if we have x1, y1 and x2, y2, which are 2 ordered pairs of a function, then the average rate of change of the function as x varies from x1 to x2 is going to be change in y over the change in x. So that's something we've seen lots before. We saw it with our equations of lines and whatnot. But now we're going to put a little twist onto it. So instead of looking at 2 points, we're going to look at 1 point and a distance away from that point. So let's take a look at a picture to kind of frame this. So if we have a function, and I'm going to draw it in the first quadrant just to make life easier for us. And let's say the curve looks something like this. So this is our function f. So the first point I want to describe is right here. So it's going to have a specific value of x, which I'm going to call x, and a specific value of y, which is going to be based off of this function f. So I'm going to call it f of x. So there's my input, there's my output. Now, instead of developing variables for another separate point, I'm going to just add a distance to this value of x. And I'm going to call that distance h. So what can I now conclude from that? Well, my new x value, algebraically speaking, should just be x, which is this distance here, plus this distance here, which we've called h. So this is going to be called x plus h. That's the new, or that's the second input that we're going to look at. So now if I wanted to identify the point on my function, so there's the point. I know the input. What is my output? Well, my output is going to be operated by f. So I have f of x plus h should be the output for that. Now what happens when I try to set up this quotient here, this average rate of change? I wanted the average rate of change between these 2 points would just be a line. So the slope of that line, what's the slope of that line? Well, I could do that pretty quickly by saying, okay, well, the change in y would be the difference between these 2 y values. So I'm going to put the bigger one first, and I'm going to subtract the second y value, but then I want to put that over the change in my x values. So I'm going to start with the bigger one, and I'm going to subtract the smaller one. Whoops. And the smaller one is just x. Now, because I'm not sure what the function is, I can't really simplify the top. But I can simplify the bottom. Algebraically, I have a positive x plus h minus x. Well, those x's will cancel. So I do end up getting this. And that is our difference quotient. It's a very powerful tool when you're looking at average rates of change of a function like this. And you're only dealing with 1 point. So again, we technically do have 2 points, but this second point is based off of the first one and this arbitrary distance h. So we really are using just one one point to generate this whole difference quotient. So we have our difference quotient, and of course we don't want h equal to 0 because then it's undefined, so that's no good. But that's our difference quotient, and it's another way to represent the average rate of change of a function. So again, just to keep the numberings correct and chronological, this should be number 7, and you saw in the previous video those numbers changed as well. But now let's see what happens when we have these difference quotients. So they're going to give you a function like this, some random function, and then they want you to plug it into that difference quotient. Now this is a little bit modified because they're telling you what x is equal to. In this case, they want x equal to 2, but they're not telling you what h is. So let's see what happens. So the first thing we want to do is find out what this f of 2 plus h is equal to based off of this function. So remember, this is the input. This input has to replace all of these x's. So we should get 2 plus h squared minus 2 times our new input of 2 plus h. And then we want to make sure we don't forget the tail end, which is a plus 4. So that whole thing is f of 2 plus h. Now we need to subtract f of 2. Well, we want to make sure we think of that as a singular object. So to do that, let's use brackets to really frame it off. So now let's substitute that 2 in. So 2 is going to replace the x, so we'll have 2 squared minus 2 times that 2, and then we still got the plus 4. So there's the first part, subtracting the second part, and we want to put that all over h. All right, so a little tedious, but it's all algebra now. We got to combine like terms, get rid of parentheses, all that good stuff. So be careful that you FOIL this out correctly. But if you do, you should get 4 plus 4h plus h squared. Now we want to distribute this minus 2 in, so be careful. Distribute the minus in as well. So minus 4 minus 2h plus the 4. So parentheses are gone. Let's get rid of all this stuff. So we got 2 squared is 4, minus 4 cancels, plus 4. So that looks like it's going to be another 4. All right, more simplifying. Can't do anything with the h squared, but looks like this 4 will cancel with this one, and this 4 will cancel with that one. So a lot of good cancellations if you do this correctly. We're going to see this the more we do. But the other thing we can do is combine our h terms. So 4h minus 2h. So we're going to have a 2h plus h squared all over h. So are we done? Not yet. We got a lot of h's in here, but we want to be careful how we cancel them. We can't just cancel them out one at a time like that. We have to look at the big picture on top, and the big picture is that we have an h we can factor out first. So factor that out. And remember, if you're not sure if you factored correctly, just multiply it back in and you should get back what you started with. So h times 2 is 2h, h times h is h squared. So we're good. But now you can cancel those h's out. So your final answer should be 2 plus h. So a little tedious with the math in that one, but very, very doable. Just got to be really careful with your notation. Make sure you use those parentheses. Make sure you use brackets on that second one. It's usually the best to do it on that second one. So, all right, let's try one more, and that will wrap up this section. So this one's a little bit trickier because we got x to the third power plus 3x. And now we don't have a specific value for x in our difference quotient. We want it vague with x plus h. So this, again, it can be a little tricky. So first things first though, x plus h is the input. That has to replace x everywhere in the function. So what do you think that's going to look like? Well, x plus h we want to keep in parentheses, but the first thing we got to do is cube it. And then we want to take, whoops, make sure we don't forget that 3. So we need a 3 times our new input of x plus h. So there's f of x plus h. Now we got to subtract f of x. So again, let's use our brackets and say x cubed plus 3x. Now we probably could have used parentheses there, but it doesn't really matter. And now it's algebra again. Okay, so x plus h to the third power. How do we multiply that out? Well, if you don't remember, let's do it off to the side. If we expand it out, we know it should look like this. Now we can FOIL 2 of them pretty quickly. So x squared, we have an hx or an xh, whichever way you like it. And then we have another xh, so we got 2 of them. And then our last would be h squared. Okay, so there's one step. Now we got to multiply this x plus h into this trinomial here. So let's do it one at a time. Start with the x. So you got x cubed plus 2x squared h plus xh squared. So that's the first step, is multiply that in. But now we want to multiply the h times every one of those. So that's going to be a plus x squared h plus 2xh squared plus h cubed. And now we combine like terms. And you can see I kind of lined it up purposefully because these two in the middle will be like terms. So that's going to end up giving you x cubed plus 3x squared h plus 3xh squared plus h cubed. All right, so let me shift this over a little bit. So we'll rewrite that. And now we got this next part we have to simplify, which is pretty quick. 3x plus 3h. And then we got the last, which is to distribute that minus sign through. So minus x cubed minus 3x. Now, if you do this correctly, one thing you should always have happen is that your original function should cancel out. If you do this correctly, it should always cancel out every time. So be really careful and make sure you distribute correctly, because if you don't, then it's not going to cancel out and then it's going to become a mess. But let's see. We got an x cubed way over here, and there's another one gone. We have a positive 3x here and a minus 3x gone. So that leaves you with 1, 2, 3, 4 terms in the top. But what do you notice about all 4 terms? They all have an h, every one of them. So that's a good thing because we have an h in the bottom that we'd like to cancel out. So you got to factor out that h out of every one of those. So that's going to leave you with 3x squared plus 3x h, because one of them gets pulled off. There's 3 of them here, so we're going to be left with 2 of them. And then we got this 3 at the end. All right, and again, double check it if you need to. Multiply it back in, make sure you get back those 4 terms on top. And now your last step is to lose the h's. And there you have it. So difference quotients can be definitely tricky. So you want to really be careful when you're substituting in those weird expressions for a variable. When an expression replaces a variable, you really want to be careful and use parentheses like we did up here. So use those parentheses around those inputs and then square them, cube them, whatever you got to do to them. So, all right, but that wraps up this section, so you can do the homework on that as well. And we'll see you in the next video for 1.5. Take care.